The overall goal of this procedure is to visualize the interior of a model battery composed of two lithium metal electrodes separated by a polymer electrolyte membrane. This is accomplished by first solvent casting a polymer electrolyte film. The second step is to assemble the samples by sandwiching a piece of the polymer electrolyte between two lithium metal electrodes and vacuum sealing in an airtight pouch. Next, the samples are galvanostatically cycled until they fail by short circuit, or as long as desired. The final step is to reduce the sample size, remove the nickel tabs, and then image by hard X-ray microtomography. Ultimately, X-ray microtomography imaging is used to show morphological changes like dendrite growth in the lithium metal electrodes and polymer electrolyte as a function of cycling.
The main advantage of this technique over existing methods like electron microscopy is that the resulting images show the interior of the electrode and electrolyte layers, revealing structures that are hidden using traditional imaging techniques.
Before beginning this procedure, synthesize polystyrene block polyethylene oxide copolymer, or SEO, using anionic polymerization as referenced in the text protocol. Perform all sample preparation in an argon glove box where the water and oxygen levels are controlled and remain less than 5 parts per million. Dissolve 0.3 grams of polymer in anhydrous N-methyl-2-pyrrolidone, or NMP, with dry lithium bistrifluoromethane sulfonamide, or LiTFSI, salt. Use an LiTFSI salt to SEO mass ratio of 0.275 and an NMP to SEO mass ratio of 13.13. This quantity of polymer will yield a membrane large enough to make a